All right, parabolas round 2 because the first one I made had no sound. Great. So, let's do it. Parabolas. You already know parabolas. So, what I'm going to do is I'm going to kind of change the order of these notes. A parabola, you know that the vertex is at h comma k. Your axis of symmetry is x equals h, which is the x coordinate of your vertex. You know if A is positive, it opens up. If negative, it opens down. We know about our x-intercept, our y-intercept. We're all good on that. But we have some new things. Focus and directrix. The focus is just like the focus of an ellipse or a hyperbola, where it's inside the graph. The equation is 4p is equal to 1 over a, though, where p is the distance from your vertex. So we are going to do the second example first. Now the reason we're going to do the second example first is because you already know how to do a parabola from chapter 5. So, first thing I want you to do is I want you to put that in graphing form, if you remember how. So go do it. So remember, your first thing is you have to get the 6 to the right side. So we have a negative 1/2 x squared minus 2x is equal to a negative 6. You must always factor out your leading coefficient. In this case, it's a negative 1/2. So we have x squared plus 4x. Remember, a negative 2 divided by a negative 1/2 is a positive 4. Half of 4 is 2, squared is 4. Now that's equal to a negative 6 minus 2. Now the reason it's minus 2 is because you must multiply the leading coefficient to the 4 before you add it to the other side. So your graphing form is y is equal to negative 1/2 times x plus 2 squared, and then this is negative 8. When we bring it back to the left, it's plus 8. So everything about this parabola is the same from when we did it back in chapter 5. The vertex is opposite of the inside, comma outside. Your axis of symmetry is still x equals a negative 2. Your x-intercepts can still be found with your graphing calculator, or you can do it by hand. Remember, if you're going to do it by hand, it's 0 is equal to, in this case, a negative 1/2 times x plus 2 squared plus 8. And we just solve by square roots like we did in chapter 5. So subtract the 8. This is a negative 8 is equal to a negative 1/2 times x plus 2 squared. Multiply both sides by a negative 2 to get this to go away. That's 16 is equal to x plus 2 squared. Square root both sides. That leaves us with plus or minus 4 is equal to x plus 2. And that's going to give us x is equal to a negative 2 plus or minus 4. Negative 2 plus 4, as you know, is 2, comma 0. And negative 2 minus 4 is a negative 6, comma 0. The y-intercept is still going to be 0, comma 6. It's when x is 0. So this is a 0 minus 0 plus 6. And everything here is what you did back in chapter 5. So I wasn't rushing through it. This is stuff you're already supposed to know. The shape, it opens down because a is negative, and it is wide because we have a fraction that is less than 1. So now we got to graph that guy. So our vertex is at negative 2, 8. Our y-intercept is at 0, 6. We know this is symmetrical, so we can put another one there. We know we have our x-intercepts at negative 6, 0, and 2, 0. You have enough to just go right ahead and graph your parabola. Make sure it looks like how you expected it. It is wide, it is opening down, and make sure you put your axis of symmetry. So everything that we've just done is something that you already know. That's why I wanted to start with this example. The new information, though, 4p is equal to 1 over a. That's the equation for finding the focus and the directrix. P is our distance from the vertex. We don't call it c because c is the distance from the center. So we're going to say p for parabolas and say 4p is equal to 1 over a. So a is a negative 1/2. So 4p is equal to 1 over a negative 1/2. Remember, dividing by a fraction is like multiplying by the reciprocal. So 4p is equal to In this case, a negative 2. So p is equal to a negative 1/2, but I'm going to tell you to not leave your p negative. There's no need. So p is 0.5 because it's a distance. Okay, just like c. Our c was always positive. The distance from the vertex. So your focus is 0.5 away from your vertex, and just like an ellipse and a hyperbola, it's inside the graph. So it goes down by 0.5. So your focus is still negative 2 comma, but it's 8 minus 0.5 since you're going down, so 7.5. Now your other new thing is the directrix. The directrix is a line that is perpendicular to your axis of symmetry. So since our axis of symmetry is a vertical line at x equals, our directrix is going to be a horizontal line, so it's y equals. And it's always the same units from the vertex as your focus, but it's on the outside. That means your directrix is a horizontal line that is above your vertex, so it is at 8.5. Okay? And that's it. That is a parabola with everything from start to finish. Everything in blue is what you did back in Chapter 5. The only new thing is the p-value, focus, and directrix. So now we're going to go back up and we're going to do the first example. And I'm going to leave the third example for class again, just like we did with the ellipses. What's different? Now it's y squared instead of x squared. So all the way back to the beginning. Notice I had these notes separated. When you have x equals, that's going to tell you that this is going to be a parabola that opens to the right or a parabola that opens to the left. That's going to change everything. So now your vertex, instead of it being opposite of the inside comma outside, look, k always goes with y. So this is y minus k now plus h. So this is now outside comma opposite of the inside. Since it's opening left and right, look at your axis of symmetry. Your axis of symmetry is now a horizontal line. That's why it's y equals k instead. Everything else is going to be the same. It's just you need to tweak your way of thinking a little bit. So let's go do this example from start to finish. The first thing we're going to do is have to put it in graphing form. So this is going to be y squared plus 2y is equal to 3 first. Half of 2 is 1, squared is 1. There's no leading coefficient, so we can just add the 1. So graphing form is x equals, this is now y plus half of 2 is 1 squared. This is a positive 4, so when you bring it to the left, it's a negative 4. It opens to the right because it's a positive y squared. The shape is still normal. So now we have to answer some new questions. What is your vertex? It's not negative 1, negative 4. It's negative 4, comma, negative 1. Because look, it's right here. This is y on the inside. So y still has to go in the y location of your coordinates. Your coordinates are not all of a sudden called y comma x. We still graph them as x comma y coordinates. So your axis of symmetry, it's now a horizontal line, so it's y equals negative 1. Our x-intercepts are now a little bit easier to find because we know the x-intercept is when y is 0. So if you go back into this equation, 0 plus 0 minus 3 is still going to give you negative 3. So now this is negative 3 comma 0. But now that makes your y-intercepts challenging to find because x is still 0, but now we have to solve algebraically to find the y-intercepts. So that's just going to be 0 is equal to, now we're going to find our y's, so this is going to be, use our completed square, y plus 1 squared minus 4. Add 4 to both sides, so this is 4 is equal to y plus 1 squared. And then we're going to square root both sides. So plus or minus 2 is equal to y plus 1. Subtract 1, and you're going to get y is equal to a negative 1 plus or minus 2. Negative 1 plus 2 is 1, and negative 1 minus 2 is a negative 3. So that's going to bring up an interesting question here in a minute. So let's graph this. Our vertex is at negative 4, negative 1. Our x-intercept is at negative 3, comma 0. And we have our y-intercepts of 0, 1, and 0, negative 3. Now, when have you ever graphed a parabola with 2 y-intercepts before? And the answer is, until now, you probably haven't. And of course, don't forget your axis of symmetry. It is a horizontal line this time because the axis of symmetry splits a parabola in half. So if the parabola is opening sideways, your axis of symmetry has to go sideways. Nice thing, though, about finding your p-value, it's the same equation. So 4p is equal to 1 over a, which in this case is 1. So 4p is equal to 1, so p is equal to 1/4, or we can call it 0.25. Where's your focus? In relationship to the vertex, it's to the right. So you are adding 0.25 to the x value. So your focus is at negative 3.75, comma, negative 1. The y did not change. Now your directrix is always perpendicular to the axis of symmetry. So now it's x equals. What number is that? You are going to go to the left of your vertex, which means you are going to subtract 0.25 from x. So that's a negative 4.25. It is a vertical line because it must be perpendicular to your axis of symmetry. And now you are done with your first sideways parabola. Okay? So that's it. You just got to tweak your thinking a little bit. Once you practice a couple of these, you'll be good to go. Now, there's one more example in the notes. I'm going to save that for class. So, this is Longo, and I am out. See you, bye.